So in chapter 4, we're talking about linear equations, and we've worked with those, linear functions, sorry. We've worked with the linear equations, and you're going to see some similarities and stuff. Okay, so in a linear function, one of the forms is f of x equals ax plus b. That's one form that they'll write it in. A lot of times we'll use an m instead of an a, but you will see it this way. But there's just one x term and one constant at the most. That's what you can have. And so the degree of this polynomial, it's a polynomial, and the degree is 1, or first degree polynomial. Okay? And then it's said to be a linear function. Now for notation, you may be used to seeing y equals mx plus b, that form, where we're going to talk about m being the slope and b being the y-intercept. So you may have seen that before. They're going to write it with the function notation f of x equals mx plus b. So you'll see it this way as well. Sometimes you'll still see it this way. Just depends on the authors and how they want to write it. Okay, so here we have an example of a linear function. And so it's a train, and the train goes 83, I think it's meters per second. Okay, and so, yeah, that's the abbreviation for meters. Okay, so for every second that goes by, it moves 83 meters. And this function here is representing the distance from the train station. This example's in the book, so you can, read it if I'm not explaining it well enough. Anyway, apparently the train starts 250 meters away from the station, which is possible. You have a lot of trains, they can't all be at the station at the same time, so it's somewhere on the track, 250 meters away from the station. And then the train's going to start going, and for every second that goes by, it's moving 83 meters. Okay? So we have these different ways to express a linear function. One is with an equation like this. And then we could also make a table. We could say, see how big I make my table here? We could say time t, that's our input, right? And d of t, that's our output. So our input we're measuring in seconds, and our output is being measured in meters. So it's always good to understand those units. Okay, so at 0 seconds, the train is 250 meters away from the station. After 1 second, well, you would have to find d of 1, and that'd be 83 times 1 plus 250. And so what's that going to be, like 333? Okay, I can add. And if you go another second, you'd add another 83 meters, which would be 416. Okay. And then if you went another second, you'd add another 83 meters, which would give you a 499. And you could keep going, as many seconds as you wanted to, but that would be a representation of inputs and outputs and how the function's working, okay, the relationship. Then we could take and we could graph that as well. So if I had a graph, and the graph, we're not going to go back in time, so we don't have any negative seconds, and our train's not going backwards, so we're not going to be going in a negative direction. But we're saying, okay, let's count by 100, 200, 300, 400. Actually, we went up to 500, didn't we? Let me make this a little bit longer. So we're saying 0 seconds, 1 second, 2 seconds, 3 seconds. I think that's what our table did, right? And so we're saying at 0 seconds, we're at 250. And then at 1 second, it was like, what, 3:33? Let me scroll back up. Yeah, 3:33. So just over like 3 1/3 kind of. And then at, let's see. Oh, I'm off, aren't I? Okay, let me move that. That was at 1 second, right? 3:33. Drew it wrong. All right, then at 2 seconds, we were like 416, so just above the 4 line. And then at 3 seconds, we were almost to 500. And so we get this linear function that's looking something like that, okay? So we can represent it with a graph as well. Okay, we talked about slope-intercept form, but I'll just go over it again. Y equals mx plus b. Or if we want to use the function notation, f of x equals mx plus b, where m is the slope, slope being how steep the line is. Slope is rise over run. We'll talk about that more in another video. And b represents the y-intercept, or where it's crossing the y-axis. So like right here, that's our 250. That's the y-intercept right there. Okay, our slope was, in this case, our slope was 83. Okay, all right. So, and you might, yeah, there's the function right there. Well, kind of d of t was 83t plus 250. So you could say, oh, if 10 seconds go by, how far from the station am I? And you could figure that out. You could evaluate it. Okay, that's it for that video.